about geysers. The main ingredients needed for geysers. I have it set up as an acronym, so we'll get to each letter. Each letter will stand for a different ingredient. Each one, very, very important. They're all equal. You take one out of the whole equation, it does not work. You cannot have a geyser. Now before I start, I just want to let you know, like I said before, 10 minutes or so this program's going to be. And also, if there are any junior rangers in the crowd, I will be able to sign off on your books. This is a ranger-led program. That's a requirement. Feel free to come on up afterwards and I'll sign those booklets for you. Now, let's get on to those ingredients. Now, that little acronym I have is very silly sounding, but it's PHEW, plumbing, heat, earthquakes, and water. You need all four of these in order for a geyser or a hot spring or any sort of thermal feature to exist. There are other places on planet Earth where these ingredients are around that have geysers. New Zealand, Iceland, and Russia are some of the biggest places. Number 2 as far as geyser basins go, just sheer amount of geysers, would be Russia. Up on the Kamchatka Peninsula, there is about a basin full of 100 geysers or so. Does anyone know how many geysers we have here in Yellowstone National Park? Any guesses?
100.
300, 100, 500. I hear 500. Nope. 500. We have 500 geysers here in Yellowstone National Park in the 2.2 million acres. 500. Like I said, Russia has 100. They're number 2. In the entire world, there are about 900 geysers to speak of. We have more than half of the geysers here in Yellowstone that there are on planet Earth. That's pretty special. It's all because of these ingredients. Now let's talk about plumbing first. And when I talk about plumbing, I'm talking about the underground waterways that take up the underside of a thermal feature. So if we had X-ray vision like Superman, we would be able to see the plumbing system for Old Faithful. Now the plumbing systems don't go very far down. This is a map of Old Faithful's plumbing system that we found out many years ago in a wild time called the 90s. We put a camera down Old Faithful. That's how we got this. Surface from here down to the bottom, where that's as far as we can get before the water started refilling and it got hot. We had to get the camera out of there ASAP. So we got 50 feet down. We found out that below the surface, 20 feet down in that 50 feet, there's what we call a constriction, a small opening that acts somewhat like a valve for the rest of the plumbing system. Down below that constriction is where the magic happens. That's where the water is collecting and boiling. This valve acts like a top on a pot of water. It's loose, it can be blown off, some steam can get through, but overall it will hold up a lot of pressure. The water here, it gets to a point where it actually flashes into steam. It goes from liquid to gas immediately. We're talking 200 plus degrees Fahrenheit. It is mind-blowing what kind of pressure and heat is down here. But once that happens though, the gas has to escape out of somewhere, right? It comes out of the constriction onto the surface and emits all of the water and steam in that system that's there. After that happens, about another hour and a half it should take for this to refill and do it all over again. That's essentially how a geyser works. This water down here boils, turns to gas, violently escapes out of the constriction, and it ends up doing it over again. That's a geyser. It has to do that periodically. You can have geysers do that once every couple of years, every couple of days, and a couple minutes. There's a geyser we can't see at the moment. It's just beyond Old Faithful on the hill called Giant Test Geyser. It takes years for that one to erupt, and when it does though, it's going to be erupting almost for 3 days straight.
Oh, wow.
That's a lot of water in its plumbing system. Now, where was I going? Oh yeah, let's talk about the next ingredient, heat. Heat is a really cool one and kind of one that I try to do my best not to talk too much about because it's super exciting and super cool. When I mean heat, I'm talking about the volcano that's under us. How many of you all knew there was a volcano right under our feet? A few of you, yeah. Hate to break it to all y'all, all the other folks. We're in a volcano, an active volcano, but that's why everything here is so dang hot. That is why all these thermal features of the water can get to 200 degrees Fahrenheit or so. Most of the hot springs you see here, the standing pools, their temperature are at least 180 degrees Fahrenheit. Good way to tell. If it's clear water, don't touch it. Please don't. You're not supposed to touch it anyways, but if it's clear, that usually means it's at least around 180 degrees Fahrenheit. Not quite boiling. Boiling at this elevation is going to be about 199 degrees. We're closer to 7,300 feet in elevation. Now, that volcano we actually have mapped pretty good. Some of you saw this before. This outline here is the rim of the volcano. We call it a caldera. It is not like volcanoes that we all have been familiar with, like Mount St. Helens or the ones out in Hawaii. Those ones are called stratovolcanoes. They erupt very differently, have different magma. This one is going to be erupting well, let's see, a good example. How many of you all have baked a pie without poking holes into it before putting it into the oven? Yeah, for those of you who have, it's messy. What will happen is that the filling or the magma will come up onto the surface. It will release pressure as the heat's being applied to it. And as the magma comes up on the surface, it will end up leaving empty space where that magma was and then collapse in on itself eventually. That process takes a very long time. These volcanoes do not erupt in our a very I'm excited so I can go so this one does not erupt very fast. In fact, I just learned recently that this could not even erupt overnight. A lot of folks that come to the park think, oh, it's gonna erupt, it's gonna be crazy, right? We're all gonna die. I'm like, oh, we're all gonna die eventually, but not by this volcano. This is gonna be something that takes a very long time. The magma here is rhyolitic, or full of silica, which means at the high temperatures it's very viscous, very spongy. If I were to go down there and actually poke at it, it would be like a little sponge, basically. So if it were to come out on the surface, it would take a long time to be emitted and go over the surface. You see these hills surrounding us right now? These are lava flows from the last time this volcano erupted, about 640,000 years ago or so. That was a while ago for humans. Geologically speaking, it was yesterday. Not even yesterday, probably the same day, just morning. But like I said, that volcano does not have any danger to be erupting anytime soon. We have, give or take a couple 100,000 years. In our lifetime, I wouldn't worry. Now the next ingredient, earthquakes. Now this is a fun one. I have a personal story for this. Earthquakes are going to be the one thing that kind of, well, I guess, they're going to be the joker in the deck, if you will. They're going to be things that change things a lot. You have an earthquake out here, geysers will act differently. Those plumbing systems I talked to you about, they're not rock solid, pun intended. I'm going to own that pun. So they actually can change with earthquakes depending on the magnitude of them. Most of the time we'll have about 1 or 2 or even smaller earthquakes out here in Yellowstone. In fact, we have thousands of them a year, anywhere between 1 and 3,000 earthquakes in a calendar year here in Yellowstone within our borders. The big ones don't happen very often. I've only lived here for about a decade or so. I've only experienced a 4.2 on the Richter scale. Now I used to live in California, and a 4.2 on the Richter scale, for those of you also from California, that is nothing, absolutely nothing. So that happened on 2015 that hit us really quick. Earthquakes out here don't roll. They don't last for seconds. They end up going, and that's it. They are a jolt. Easy peasy, right? It actually jolted me out of bed. The epicenter wasn't very far from here, so I popped out of bed, woke up, and thought nothing of it. I had heard about earthquakes and what it was all about, and thought, oh, okay, this is another day. I go to the Old Faithful Inn, I get on the balcony, I get my ice cream, and I wait for the Old Faithful eruption time, which was actually around this time, 12:30ish or so. And people are telling me, oh, that earthquake was so cool, it was awesome. And again, 4.2, oh, it was all right. I go to Old Faithful. 12:30 comes and goes. Old Faithful hasn't erupted. 1 o'clock goes by, still has not erupted. A whole 2 hours and 45 minutes went by before Old Faithful erupted again. During that time, though, there was an hour there where we all thought Old Faithful had died. I saw all over social media, Old Faithful's dead. Everyone's out of the job. Oh no, oh no, oh no. I got calls from my parents. Are you alive? What's going on over there? It was wild, but it erupted. It went back to its 1.5-hour eruption times. What we think happened is that constriction I talked about, remember I told you, well, I didn't tell you, it's about the size of my fist, that constriction. It is small. So most likely what might have happened, because we don't have confirmation, just theorizing here, is that constriction got obstructed somehow, but was able to rock itself loose from the pressure that was built from Old Faithful's eruption. That eruption there, though, was almost 200 feet. Old Faithful's average is about 145. Wow. I love telling this, that's not even the tallest geyser we have out here. This is a nice geyser. I love it, don't get me wrong, but if you want to talk about heights and such, come to me afterwards. I got a list. But here's a picture, kind of give you an idea of earthquakes here in the park. So this is going to be from 1973 to 2001. All the red dots on this little map I'm about to show is an earthquake. The big ones, the yellow stars, are going to be the 4.0s. This is a lot of time going by, but this is what a map typically looks like even within a year or so of recording those earthquakes. It's a lot. All right, and the last ingredient, water. Now, the water you're going to see coming from Old Faithful had to go through a very long journey before it got to where it is now. So, the way that it starts as a snow melt and rain. A very long time ago, melts, ends up making its way down into the plumbing systems of the thermal features, and some of it makes its way down towards the volcano. Now, before it gets to the volcano, the molten stuff, there's a couple of layers of superheated rock that are there before the magma. So that water hits the superheated rock, becomes less dense, and then rises to the surface. This is a simple way to kind of describe exactly how that goes. Now that whole process that I explained to you guys, what was that, 20-ish seconds, maybe 15? That whole journey from the surface down to the superheated layer of rock, back up, can take hundreds of years. It is a long time. Anyone want to guess how old Old Faithful's water might be? Because we actually can measure that. Any guesses?
500 years.
500 years. Right here, anyone else? 500.
Million years.
Million years. Million years. Right here, another million.
1,000 years.
1,000 years. Closer to 500 years.
Oh.
That's how old that water is. You win. That is going to be water that started its journey when Columbus was lost somewhere in the Caribbean. That water is older than the foundation of this country. Think about that. That is old water. So when you see it, not only is this a great show of Mother Nature, that water went through a journey to get to us. Let's congratulate her for coming on back. Let's not update it about what's going on right now, okay? Let's just let it go back and then come back and we'll see what happens. But those are the main ingredients, y'all. P-H-E-W. Now, I'm going to test you real quick. P, what's that stand for? Plumbing.
Plumbing.
H.
Heat.
E.
Earthquake.
W.
Water.
Awesome. Now there's a secret ingredient that I like to add. It's an extra P at the end of this, so it sounds like phew. Very silly sounding, but that last P is very important. It stands for preservation. You can have all these ingredients anywhere on planet Earth, but if you do not preserve these features like we have done here in Yellowstone National Park, these go away. A great example would be, a bad example would be the geyser field that we had in Bayaway, Nevada. Northern Nevada, there was a geyser field out there comparable to what we have out there in Geyser Hill. Tons of different little geysers erupting at different periods of time, different kinds of hot springs. It was like a little Yellowstone National Park. What ended up happening was that there was no preservation effort. There were efforts, but they just didn't come through for some reason or another. And what ended up happening was that they opened a hydrothermal plant next door. They tapped into one of the ingredients. They tapped into the heat, they tapped into the water. They took two ingredients away. And then those thermal features were gone within a year. They are now permanently gone. There's no way they would ever come back. That's a good lesson for us to learn for what not to do with our thermal features. We have thermal features here because we have protected them. Yeah, they could have energy. You have enough to power Bozeman, Montana from the thermals that we have here in Yellowstone. Just one city, that's it. Not the whole United States, just one town, about the size of that place. So, there's only 700 us rangers out here in Yellowstone National Park at any given summer. There's almost 5 million of you guys here every year. We need to work as a team to be able to keep this place preserved and make sure that these don't go anywhere like Bayaway or anywhere else on planet Earth. So let's work together. We can make this place last even longer than the 151 years it's already been here. Thank you for joining my program. If you got any questions coming up, Junior Rangers, come on up. Oh, good. I didn't have to compete with the geyser. I go over sometimes on that.